All right, guys, we're going to start chapter 6. Chapter 6 is all about transformations, so it's going to be a lot of drawing things, a lot of looking at pictures and seeing how they change. Not a lot of calculations in this chapter, though, so if you don't like calculations, you're in luck. So chapter 6 starts with the idea of single transformations. So 6.1 is all about single transformations, or just doing one transformation at a time. So when you move a shape or object from one location to another, for example, by sliding it sideways or rotating it around a point, you're performing a transformation. In industry and business, transformations are used in many situations. In this chapter, you will work with 4 types of transformations as shown on the following pages. Okay, so just know what a definition of a transformation actually is. So it's movement of a shape or an object by changing its position, size, and/or shape. Okay, the first one we're going to talk about is a translation. Translation is when we move a shape or object horizontally and/or vertically. The thing to remember about a translation is it does not change the size or shape of the object, just the location. So it's kind of like we're sliding the shape around the page without turning it. Okay, so a translation doesn't change the shape or the orientation or the size of the object. All it does is slides it around. A reflection is when we create a mirror image of a shape or an object over a reflection line. Okay, so this is like if you were in elementary school and you ever made butterflies and you painted on like one side of the wings, you folded it in half and you got paint on the other side. That was creating a mirror image or a reflection. This is the same thing here. If I look at this triangle up top, if I could fold this piece of paper directly in half along this x-axis, it would end up over here. So a reflection is a mirror image created by transforming the image over a reflection line, and a reflection line is a line across which a figure is reflected. Okay, then we have rotations. Rotation is moving a shape or an object around a fixed point. So if this was our center point, we're going to turn everything the same amount, and it creates our new shape or our rotation. It's as if we're spinning it around that center point. And then the last type of a translation you guys need to learn about is a dilation. A dilation is an enlarging or reducing a shape or object to create a similar figure. Dilation is the only translation that changes the size of the shape. Okay, nothing else makes the shape a different size but dilations. Okay, we're going to start with translations though, because translations are the easy ones. So translation occurs when a shape or image moves up, down, right, or left without changing size or shape. Each vertex of the shape will move the same distance in the same direction. This is kind of the key to doing a translation. Each vertex moves the same distance in the same direction. So our example says, translate the following shape 6 units to the right and 2 units down. What are the coordinates of the resulting vertices? Okay, so vertices are any of the points, any of the corners. Vertices is another name for that. And units are just how many spaces or how many lines you're moving over. So the easiest way to do that is take each one of your vertices and move each one of them as far as it says. So in this case, it says 6 units to the right and 2 units down. So if I start at A and I move it 6 to the right, so 1, 2, 3, 4, 5, 6, and 2 down, my A ends up right here. And because it's my new, not my original, my new object, I call it A prime to show that that's where it is after the translation. Same with E. I'm going to go 6 over, 2 down. E ends up right there, and I'm going to call it E prime. B is 6 over, 2 down. That's where B prime is. D is 6 over, 2 down. And C ends up right there. Draw my lines. Color in my shape if I really want to. I don't care that much, so I'm not going to. That's where my new shape now is located. That's not the only thing it wants, though. It wants the coordinates as well. Coordinates are always an x value and then a y value. To find our x value, if we're going on this side, this is our positive x numbers. Up to the top is our positive y. To the left side is our negative x. And at the bottom is our negative y. So I always figure out from my origin, which is right here at 0, 0, how I get to my coordinates. So if I get to A, I have to go 1, 2, 3, 4 to the right to get to A, and I don't have to go anywhere up or down. What that tells me is my x value is positive 4, because 4 to the right, and my y value is 0, because I didn't have to go up or down. To get to E from my origin, I have to go over 6 and down 2. So this is over to the right 6, down 2 in the y. For D's in line with E prime, so I know I'm going over 6. So right 6 is positive 6. And from this line, I'm going down 1, 2, 3, 4, 5. So my y value is negative 5. To get to C, I have to go from my origin, right 2. So 2, down 1, 2, 3, 4, 5, so negative 5. And then my B value, I go right 2, down 2. So 2, comma, negative 2. Those are my coordinates of my points. Okay, the rest of this is just showing you how to do it. They like to do a way where you add and subtract to the original coordinates. I find that more difficult, but if this works for you, it'll work every time as long as you're careful. So read through this, see if you like this version. I like to simply just move it across on the graph paper because I already have those grid lines and I know what I'm supposed to be doing because of the words. So they end up with this shape right here, exact same as what we had. Okay, so this next one says translate the shape 5 units to the left and 3 units down. What are the coordinates of the vertices of the translated image? So when you're doing this, you want to pick the points that are at nice crossing places. So A, B, C, D, and E. I don't want to pick a point somewhere like this because to move that over and down, it doesn't line up properly on my grid, which makes it harder to estimate where it's going to go. Pick vertices, pick corners that are in nice, easy, measurable places. So this one says 5 units to the left, 3 units down. So each one of my vertices is going to move 5 to the left, 3 down. So 1, 2, 3, 4, 5, 2, 3 down. This is going to be B prime. 1, 2, 3, 4, 5, 1, 2, 3. A prime. 1, 2, 3, 4, 5, 1, 2, 3. C prime. 1, 2, 3, 4, 5, 1, 2, 3. D prime, and then 1, 2, 3, 4, 5, 1, 2, 3. E prime. Get rid of all my little dots. It's hard when the shapes overlap, or harder when they overlap. Once you get your vertices, look back at your original to see what kind of shape it should look like, so that you connect your dots back in the right pattern. Okay, so that's where my shape is, what my shape should look like. I moved every corner, every vertices to the left 5 and down 3. It also, though, wants the coordinates. And the coordinates are always measured from the origin, this very center. So if you start at this center, how do you get to each one of your coordinates? So to get to E, I have to go to the right 1, and I have to go up 1. So this is right 1, up 1. So both are positive. And then my positive X direction, my positive Y direction. To get to D, I go to the right 1, 2, 3, 4, and then I go up 2. So this is going to be right 4, up 2. To get to C, I go right 1, down 2. So down 2 is going to be negative 2 for my Y. To get to B, I go left 2 in my X, so negative 2 in my X, because this is my negative X direction. This down here is my negative Y direction. So I'm going negative or left 2, but I don't go up or down. I stay on my axis, so I'm going to have 0 in my Y. And then to get to A, I go left 1, so negative 1, up 3, so positive 3. Those are my coordinates for all of my new prime vertices or my new translated vertices. Okay, so it says, the next one says parallelogram ABCD is translated such that vertex A moves to A prime of 2, negative 1. Draw the other vertices of the translated parallelogram and state their coordinates. So it says that A starts out over here, and it moves to 2 in the X and negative 1 in the Y. So 2 in the X, negative 1 in the Y is right here where they've drawn A prime. We have to move all the other vertices the exact same amount. So the first thing we want to figure out is how far we had to move things to get to there. So to get to from A to A prime, we had to move to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. So this was right 9. And then we had to go down 1, 2, 3, 4. So that means we're going to move every single vertices in the exact same way, and that's going to give us our same shape in the end. So for B, we're going to go right 9, down 4. C is going to be right 9. 1, 2, 3, down 4. Same with D. So my new shape looks like that. Again, it should look exactly the same if you use the ruler. Should still be the same shape as it started with. So now it wants the coordinates. So we already know A prime because that was in the question. So this is 2, negative 1. Again, we're always starting at that center origin to count our coordinates. So to get to B, we go right 1, 2, 3, 4, 5, 6. We don't go up or down off the axis, so it's 6 and 0. C prime is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right, and down 4, so minus 4 for the Y. And then D is going to be right 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. Those are my coordinates of my new parallelogram. Okay, the next one is just asking you how far does it move horizontally and how far does it move vertically. Horizontally is always left and right. Vertically is always up or down. So horizontal is this way, vertical is this way. So for my horizontal, it went 9 units right. For my vertical, it went 4 units down. All right. 1, 2, 3, 4. Yeah. Okay, the other thing it can ask you to do is figure out if something is actually a translation of your original. If it is a translation, all the vertices move the same amount. Okay, so they're all right 2 up 3, or they're all left 4 down 1. It doesn't matter what it is, they all move the same amount. Some of them, just by looking at it, you can kind of tell they're wrong because the shape has changed. If I'm looking right here at my original, to me, 3, this piece of 3 looks like it's squished. It doesn't look like it lines up properly anymore. And so if it doesn't line up properly anymore, it's probably not the same thing. It's hard to tell though, just by looking at it. The easiest way to tell is compare your vertices. So if I look at my original, and I want to compare it to number 1, this top corner and this top corner look like they're in the same position. So to get from C to what I'm going to call C prime, I need to go 1, 2, 3, 4, 5, right? And down 1, 2, 3. That means every other point on my shape needs to go right 5, down 3. So for D, if I go right 5, down 3, I hit my next point. For A, if I go right 5, down 3, I hit a point. B, if I go right 5, down 3, everything matches up. So it looks like shape 1 is a translation of A, B, C, D. I can check my other shapes as well. If I look at C to this top point, I had to go right 5, 6, 7, 8, 9, and up 3, which means from here I should go over 9, 5, 6, 7, 8, 9, and up 3, which means my D prime should be right here, and it's not. Since it doesn't match up, this is not a translation. It's a different shape now. And then I can check 3 as well, doing the same thing. I'm going to check from A and B maybe. So to get to this point here, I have to go 5, 6, 7, 8, 9, 10, 11, and down 2. This from B is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, down 2. My next point should be right there. It's not. It was down here, which means this is also not a translation. So shape 1 is a translation. And it says, how far did it move horizontally and vertically? For horizontal, which is left and right, we said we moved right 5. For vertical, we had to go down 3. So that's where our translation was. Okay, a more common way of doing this is maps. Maps tend to use a version of translations. You're someplace and you want to translate yourself to somewhere else. You want to move around. So this one says Michelle's using the map below to find her way around town during a holiday, and there's some stuff labeled on the map. The next page says Michelle's at the store and needs to walk to the bank. How many grid units and in which direction does she need to travel? So she's going from the store to the bank, and it wants the directions, which is north, south, east, west. It's given us right here that up is north. If you guys aren't familiar with your directions, north and south are opposite to each other. East and west are opposite to each other. So to get from the store to the bank, she needs to go up 2 units. So 2 units north. And then she needs to go 1 map unit to the left, and the left is west. So if you flip to the next page, so she's at the store, needs to walk to the bank. How many grid units and in which direction does she need to travel? So she needs to go 2 units north and 1 unit west. The next one says, how many meters north and west would you have to walk to get from the school to the sports fields? So if we go back to the map, we're starting at the school. I want to get to the sports fields. So from the school, sports fields are up here. We need to go 2 units this way, and that direction is our west direction. And then we have to go 1, 2, 3 up, which is our north direction. It's not actually asking us how many units in this question, though. It wants to know how many meters. And if we look at a map always has some sort of key or legend that tells you how big the spaces on the map represent in real life. This is saying each space is 500 meters. So I'm just going to go back to the other page. So for the north direction, she went 2 units. Oh, sorry, 3 units north. And we know each unit is 500 meters. So 3 times 500 is going to be 1,500 meters north. In the west direction, on our map we said this was 2 units. Each unit is 500 meters. So 500 times 2 is 1,000. So she goes 1,000 meters west. Okay, that's kind of it for translations. That's about as tricky as they get. Slide things around, figure out how far they've gone. The next new skill is reflections. Reflections are slightly harder to wrap your head around. Basically, it starts off with mirrors. When you look in a mirror, you see a reflection of yourself. A reflection is a transformation of a shape or an object that creates an identical image across a reflection line. This is an identical image. The points of the image will be the same distance from the reflection line as the points of the original shape. This is kind of important if you're not good at visualizing this. You're going to want to be able to count how far away things are and put them in the same place across the line. If you were to draw a shape and its reflection on a piece of paper, and then if you folded the paper along the reflection line, the original shape and its image would match up. Okay, so this one says, draw a mirror image of this letter reflected over a horizontal line. So the line we're reflecting over is this dotted line. Okay, this isn't going to end up as an R down here somehow. When you reflect something, that something flips over. So anything that's directly on the line is going to stay directly on the line. And then the further away a point is, the further away we draw it in the opposite direction. So to get to this point up here, I have to go 1, 2, 3, 4 units up to it, which means my reflection, I'm going to go 4 units down. To get to this point right here, I had to go up 2, which means I'm going to go down 2 to get to that point again. From that point, I go back down to my my reflection line. So I go back down to my reflection line, across to here. This point right here is 2 up. So I go down 2, and that's my next connector. Curves are harder. I would maybe use this point right here as my first point. So that one goes 1, 2, 3 up. So from there, I need to go 3 down. My curve is kind of going to stop somewhere in there. This point up top is 1, 2, 3, 4 up. So 1, 2, 3, 4 down is going to be the other half of my curve. And then straight across. Okay, this should hopefully be easier for you guys, paper and pen, than it is on the whiteboard. This guy, those 2 points, so 1, 2.5 up. So 1, 2.5 up. The top one is 1, 2, 3.5. So 1, 2, 3.5. So somewhere there, kind of there. Makes the same shape but upside down, or it should, if you're lucky. Okay, if I could fold my paper along this reflection line, they would exactly line up. That's the purpose of a mirror image or of a reflection. Okay, this E, same deal. This time we've got a vertical reflection line. So that means as far as the points are to the left of the line of reflection, they're going to be to the right. So if I start here, this point is 3 units to the left. So my first one on the other side is going to be 3 units to the right. From there, I go down 1, 2, 3, 4, 5 units. So I need to go down 5 units. Up and down doesn't change. Then it comes back to my line of reflection, so I need to come back to my line of reflection, and anything that's on that line stays exactly the same. Now I go 2 units to the left, so 2 units to the right, 1 up, so 1 up, 1 back towards my line, so 1 back towards my line, 1 up, 1 up, 1 away, 1 away, 1 up, 1 up, 1, 2 back, 2 back, and there's my last one. So again, if I could fold this directly in half, I would have half of the E on one side of my vertical line, the 3, I guess, on the other side that would line up exactly along that line. Okay, so here it says when a shape is reflected over a horizontal line, the image will appear upside down. Each point of the reflected image will be the same distance from the reflection line as in the original. So theirs is prettier than mine. I'm sure yours is as well. And then if you reflect over a vertical line, the image will appear backwards. So here too, each point on the reflected image will be the same distance from the reflection line as in the original. So the E, when you flip it over, becomes a 3 on the other side. Okay, so this one says write your first name in capital letters, then reflect it over a horizontal reflection line. So if I was going to do mine, you're going to do your own. Luckily, none of you have super long names. Write it in capital letters. And then you're going to have your reflection line underneath. You're going to flip them so that they go this way somehow. Something like that. They flip over that reflection line. So the points that are close stay the points that are close. The points that are far away stay far away. Okay, do your own names. I think yours are all probably easier than mine. And then next one says, are there any letters of the alphabet when written as capital letters that look the same after they've been reflected over a horizontal line? That is when they're flipped upside down. If so, what are they? So I'll leave this one for you guys to figure out. Figure out if any of them look the same. The next little bit, reflect the following image over the indicated vertical reflection line. So the line is this dotted line, which means our shape, everything is going to be equally distance away. So if we start at the top, we go away 2. So we're going to go away 2 in the opposite direction. Down 1, back in, down 2, and across. Be careful if there's patterns or shading in your original. That shading needs to be there too. So this box right here was shaded in, which would be this box on our new one. This box over here was shaded in, which means this box on our new one would also be shaded. So if it has some sort of pattern to it, you have to do the pattern as well. Okay, triangles are harder. The next one's a triangle. It says reflect triangle ABC over the y-axis. Label the vertices A prime, B prime, and C prime. So over the y-axis, that's this guy right here. So that means this shape on this side is going to flip over onto this side. Okay, so point A is right here. It's 1 unit away from my y-axis, which means my new one is in the same position, but 1 unit away from my y. C is here, and it's 1, 2, 3, 4, 5, 6, 7 units away, which means if I start at the same place, I need to go 7 units away in the opposite direction. So 1, 2, 3, 4, 5, 6, 7. B is up here. It's 1, 2, 3 units away, which means I need to go 3 in the opposite direction. B is going to be right there. And when I connect my dots, I should get a shape that's exactly the same, just flipped over. The size shouldn't change, the angle shouldn't change. Okay, so there's my new one. It says label the vertices A prime, B prime, C prime. That was the first one. Now it says reflect triangle ABC over the x-axis. The x-axis is this one right here, which means this shape is going to be flipping down onto this side. So to get my ABC, when I look at point A, I had to go up 1 from my reflection line, which means I have to go down 1 to get my new one. It says label them with the double prime, so A double prime. B, I had to go 1, 2, 3, 4, 5 away from my reflection line, so I need to go 5 in the opposite direction. So B prime is going to be down there, or B double prime. C was 3 up, which means I have to go 3 down. And I connect my shape again. Okay, again, it's exactly the same shape. It's just reflected or flipped over whatever line that it's told me to do it over. So in this case, the y-axis and then the x-axis. Okay, if you look, they've given you kind of an example. They've told you the coordinates. You don't have to worry so much about the coordinates if you like to just draw them. Our answer looks the same as their answer. Just be careful with how you label it. Okay, the next one is about reflecting our shape over the y-axis again, over the x-axis again. So the first one is reflect the shape over the y-axis. So across the y-axis, which is this guy. What that means is this shape is going to end up over here somewhere. It's going to flip over that line. So any point, starting point, it doesn't matter. A was 3 away, so we need 3 away to be A prime. E was 1 away, so E is going to be 1 away. G was left 3, so we're going to go right 3. I'm going to put that on the other side. C was also 3 over. So 3 the other way for C prime. B was up here in line with E, and it was 1, 2, 3, 4, 5 away. So 1, 2, 3, 4, 5. B ends up over there. Connect my dots back into the same shape they were in to start with. The second one says reflect the shape over the x-axis, which means this is going to end up here because my x-axis is this line over here. And it says label the vertices with the double primes this time. So now our reference point is the x-axis. So we need to count away from the x-axis to all of our points. So to get to E, I had to go down 2, which means my new E is going to be up 2. A was down 1, so I'm going to go up 1 to get to the new A. B was down 2, so in the same line I'm going to go up 2. D was down 3, so I'm going to go up 3. And C was down 1, 2, 3, 4, 5, 6, so I'm going to go up 6. Up there. And when you connect these in nice straight lines using a ruler, you're going to get the exact same shape, only flipped over that x-axis. Doesn't ask for coordinates, don't worry about coordinates. Next example says Rupinder is creating an image that will be printed on a t-shirt. In order for the image to appear correctly on the t-shirt, he needs to draw a mirror image of it reflected over the y-axis. Draw the reflection. So over the y-axis is over this line, which means I would fold it along that line, which means this side is going to end up over here somewhere. So I'm using my y-axis as my reference point. This is over 1, so my new point is going to be to the right one, so it's going to be the left one. This is to the right one, so my new point is going to be to the left one. To get to here, I go right 1, 2, 3, 4, so left 1, 2, 3, 4. Up here, this is again right 4, so left 4. This little peak of the triangle is 1, 2, 3, 4 as well, so 1, 2, 3, 4. This peak of the triangle is 1, 2, 3, 4, 5, 6, 7 to the right, so 7 to the left. And then this last vertex is 4 over, so 1, 2, 3, 4 in the opposite direction. Connect all my lines. There's my shape reflected over the y-axis. Okay, the last little bit says, in the previous example, you reflected an image over a reflection line to create 2 symmetrical images. It's also possible for a single image to be symmetrical about a line. That is, the image can be folded in half to create a mirror image on either side of the line. This is basically drawing your lines of symmetry. So you guys have done this before. So a line of symmetry is any place that you could cut up a letter or an object and fold it in half and it would exactly line up. So A, what they're saying is A has a line of symmetry. If you cut it right down the middle, you could fold the 2 halves together and it would directly line up. C doesn't have a vertical one, but it does have a horizontal. If I folded it right there, the top and the bottom would be exactly equal. R doesn't have any. There's no place that I could cut that or fold it to make it line up. But D I could do vertically. H has 2, a vertical and a horizontal. And U has a vertical line as well. Okay, so they're either going to ask you to find your lines of symmetry, or they're going to ask you to draw your lines of symmetry. So if they ask you to use a line of symmetry, what they want you to do is complete the drawing as if you could fold it across that line. This is the same thing as what we've been doing with a line of reflection. So we kind of map out where our points would be. So the top of the star is going to be there, the bottom of the star is going to be here. This point would be 3 over, so we need 1, 3 to the opposite direction. This point is another 1, 2, 3, 4, 5 from that last one. So to there. This point down here is 3 over from our symmetry, so 3 over. This guy down here is probably our last important one, and it's 1, 2, 3, 4, 5, 6 over. So there. And then we're going to connect our dots. It should hopefully give you something that's exactly the same on either side. Same here. We're up 2, so down 2. Comes all the way across to here. At this point, this little peak goes up 2 more, so down 2 more, and then meets up with the front of the arrow. Last part says examine the following flags and determine any lines of symmetry that exist. Consider the shape only, not the color. So is there any places on these flags where we could cut them and have it be exactly the same on either side? The more complicated the shape, the more or the less lines of symmetry there tend to be. So when I look at the Canada flag, the only line of symmetry is going to be straight up and down. Because if I folded this left half and this right half, they would exactly match up one against another. Austria's flag, if we're not worrying about color, looks like I could cut it exactly down the middle. And I could also cut it down the middle horizontally. And those rectangles, those bars would line up on either side. The UK one doesn't actually have any, even though it kind of looks like it does. And the reason why it doesn't is because these alternate right here. This is black, this is white, whereas this is black, this is white. So if I tried to fold it and have them match up, this black piece right here would line up with this white piece right here, and it would have no symmetry. Although I guess if we're ignoring color, it would maybe work. But I would say this has no lines of symmetry. And the same reason we can't do it straight across, because this black piece, again, would line up with this white piece right here. They would be opposite, it wouldn't work. India's flag, as long as all those little lines are exactly the same, looks like we could do it straight across, straight up and down. Brazil's going to have none. Because none of these stars, if I cut it, line up exactly the same. The words don't line up exactly the same. Same with here. If I cut it this way, these words don't appear down here. So it has no lines of symmetry. And the South Korea flag is also going to have no lines of symmetry because none of these symbols are exactly the same. There's no way to cut this so that this and this are exactly the same. Or these guys are the same. So South Korea is going to have none. Okay, I think we're going to stop for there. We're going to save rotations and dilations for your next set of notes. So what that means is for now, you're going to be able to do some of the homework section already. So if you go to the practice your new skills, so page 237, you should be able to work on question 1, all of question 1. You should be able to do question 2. 3 is a rotation. 4 is about symmetry. 5 is about dilations. And that's it for now. So at least 1, 2, and 4 you could start working on already. If you can figure out rotations on your own, feel free to move on. But you guys need to at least accomplish this much. Your next video will be the rest of 6.1, so rotations and dilations.